Imagine this. You're standing in the heart of a bustling city gazing up at the sky. Above you, thousands of satellites are silently orbiting Earth, sending signals for communications, weather forecasts, navigation, and even monitoring climate change. Now picture this. One of those satellites, a critical piece of technology, is suddenly struck by a fast-moving object from space. You can't see it coming. You don't hear it until it's too late. The satellite is obliterated, its purpose lost forever. The cause of the collision? Space debris, the unwanted remnants of human activity in space. It's a growing threat, one that could endanger not only the satellites we rely on every day, but also the very future of space exploration itself. But how did we get here? How did space, once the realm of uncharted frontier, become a dangerous minefield of junk racing at speeds fast enough to destroy everything in its path? And what does this mean for the future of space missions, missions to the Moon, Mars, and beyond? This is the reality we face. Space debris isn't some fictional scenario, it's happening right now, and it's growing exponentially. According to NASA, there are over 34,000 pieces of space debris larger than 10 centimeters, and more than 100 million pieces smaller than 1 centimeter. But don't be fooled by their size. Speed is what makes them dangerous. These objects travel at speeds of up to 28,000 kilometers per hour, roughly 22 times the speed of sound, and a collision, even with something as small as a paint chip, could severely damage or destroy valuable satellites. So, how did this mess come to be? To understand the magnitude of the problem, we need to take a step back in time, all the way to the beginning of humanity's journey into space. Let's rewind to 1957. The Soviet Union launches Sputnik, the world's first artificial satellite, into orbit. It was a small, shiny sphere, a triumph of human achievement, and a sign that the space race had officially begun. But Sputnik wasn't just a symbol of progress. It was the first of many objects to be left behind in space. In fact, every rocket launch leaves some kind of debris in its wake, whether it's discarded rocket stages, fragments from previous missions, or broken parts from satellites that have outlived their usefulness. With every new launch, more and more space junk was created. And this wasn't just a temporary problem, it's one that would only grow. By the late 20th century, the number of satellites in orbit was steadily increasing. In 1985, there were only around 1,000 satellites in orbit. But by 2025, that number will exceed 10,000. As more nations and private companies get involved in space exploration, the amount of debris continues to skyrocket. Satellites are launched, some fail or reach the end of their lifespan, and instead of being safely decommissioned, they're often left to drift in orbit, uncontrolled, and when that happens, things get dangerous. Now, let's talk about the danger itself. Imagine you're in a spacecraft traveling at high speeds, moving towards a space station or an asteroid. You know the odds are low, but a collision with even a tiny fragment of debris could cause catastrophic damage. It's a bit like driving a car at 100 miles per hour, but in a minefield, one tiny rock could cause a devastating crash. The speed at which space debris moves is what makes it so destructive. Even a tiny piece of debris, weighing only a few grams, can have the impact of a large, heavy object. The forces at play are immense, enough to tear through metal, shatter glass, and cause a catastrophic failure in a satellite or spacecraft. The infamous 2007 Chinese anti-satellite missile test serves as a chilling reminder of the dangers posed by space debris. In an effort to demonstrate its growing military capabilities, China shot down one of its own weather satellites, destroying it in the process. The result? Thousands of pieces of debris were sent hurtling into orbit. Some of these fragments remain in space to this day, adding to the already dangerous cloud of debris around Earth. Then there was the collision in 2009 between an operational Iridium communications satellite and the defunct Russian satellite Cosmos 2251. The two objects collided at a speed of around 11 kilometers per second, creating thousands of debris fragments that posed a danger to other satellites for years. This incident demonstrated that space debris wasn't just a theoretical issue. It was real and it was happening. But here's where things start to get even scarier. Space debris is not just a threat to satellites, it's a threat to the very fabric of our space infrastructure. The International Space Station, which orbits Earth at around 400 kilometers above the surface, is in constant danger from space junk. Even though the ISS is equipped with shields designed to protect it from small debris, a collision with something larger could be catastrophic. In 2020, a small piece of debris caused the ISS to change its orbit just to avoid a potential impact. The danger is real, and it's growing every year. Now let's think about the future. Human ambition is taking us farther than ever before. In the coming decades, we'll be sending astronauts back to the moon, establishing permanent lunar bases, and even preparing for manned missions to Mars. But here's the question. Will we be able to launch these missions if space around Earth is too crowded with debris to navigate safely? If we don't start managing the junk we've left behind, we could soon find that space isn't a place for exploration, it's a place of peril. At the heart of this issue lies something called the Kessler syndrome. First proposed by NASA scientist Donald J. Kessler in 1978, this theory suggests that if the density of space debris in low Earth orbit becomes too high, it could trigger a chain reaction, a self-perpetuating cycle in which debris collides with other debris, creating even more debris. This cascade of destruction could render large areas of space unusable for future missions, essentially turning Earth's orbit into a massive junkyard. And it's not just a theoretical problem anymore. Scientists are already tracking thousands of pieces of space junk, and the more we send into space, the more we increase the risk of a catastrophic event. So what's being done about it? Well, that's what we'll explore in the next section. From groundbreaking space cleanup technologies to international efforts to reduce debris creation, the solutions are beginning to surface. In the next section, we'll explore the science behind space debris and how it affects the missions we rely on for communications, navigation, and even scientific discovery. You'll see how this problem extends far beyond just a few lost satellites. It's a threat to our entire infrastructure. But what can be done to fix it? Stay with us. As we continue to explore the ever-growing threat of space debris, it's important to understand how this junk is not only created, but also how it interacts with our satellites, spacecraft, and missions. Imagine being an astronaut aboard the International Space Station, floating high above Earth's surface, going about your day. You're hundreds of kilometers from home, surrounded by the beauty of space, the stars twinkling in the distance, the Earth below a perfect blue and green marble. But suddenly a warning alarm blares. The crew is told to strap in. A piece of space debris, moving at tens of thousands of kilometers per hour, is heading directly toward the station. It's not a hypothetical scenario. In fact, this kind of near miss has already happened. In 2020, a small but significant piece of space junk came dangerously close to the ISS, forcing the crew to alter its orbit to avoid a collision. The frightening part is that this is not an isolated event. According to NASA, space debris poses a constant risk to active spacecraft. A collision with a piece of debris, even something as small as a paint fleck, could puncture the hull of the space station or spacecraft, leading to catastrophic damage. Space isn't empty. It's crowded with debris, and it's becoming more dangerous by the day. So how did we get here? What makes space debris so much more than just litter in the cosmos? The answer lies in the nature of how space debris is created. Every time we launch a satellite or rocket, parts of that mission are discarded. Rocket stages are jettisoned into orbit, sometimes remaining there for decades. Satellites reach the end of their useful lives and are often left to decay slowly, circling Earth as they drift farther and farther from their intended trajectories. But it doesn't stop there. Collisions between objects in orbit, whether they're satellites, rocket parts, or even tiny pieces of space junk, create even more debris. These collisions send fragments scattering in all directions, each one becoming a new dangerous piece of debris in the sky. One of the most notorious events that accelerated the space debris crisis was the 2007 anti-satellite test by China. In an effort to show military strength, China destroyed one of its own weather satellites with a missile, scattering thousands of pieces of debris into orbit. The result? A dangerous cloud of fragments, many of which are still in orbit today. And it wasn't just the Chinese missile test that contributed to the debris field. It was the practice of launching satellites and missions without proper end-of-life plans. Satellites weren't deorbited safely, and the debris from collisions kept adding up. In fact, after the Chinese test, some pieces of debris from the destroyed satellite remained in orbit, adding to the already crowded space environment. But it's not just the big events like missile tests or collisions that make space debris so dangerous. The everyday activities of spacefaring nations and private companies add to the clutter. In 2009, an operational American communications satellite, Iridium-33, collided with the defunct Russian satellite Cosmos 2251 in a catastrophic event that created thousands of debris fragments. These fragments now pose a direct risk to any spacecraft passing through the same orbit. The collision showed how quickly things could go wrong, and how little time we have to prevent such accidents from escalating into bigger disasters. Now, let's talk about the velocity at which these objects travel. It's critical to understand that space debris doesn't just float lazily in orbit. It moves at speeds up to 28,000 kilometers per hour, about 22 times the speed of sound. At this speed, even the smallest fragments of debris have the potential to cause massive damage. A collision with a piece of space junk as small as a marble could tear a hole through the hull of a spacecraft or satellite. It doesn't matter. Whether you're in a high-tech satellite or a simple piece of equipment left behind, if it's hit by debris moving at such high velocity, the consequences are severe. The impact could disable the satellite's systems, or worse, send it into an uncontrollable tumble, rendering it useless. And that's not even considering the danger to human lives aboard space stations or during space missions. You might be wondering, how can we even track all of this debris? The truth is, tracking space junk is a complex and growing challenge. NASA and other space agencies around the world track more than 20,000 pieces of debris larger than 10 centimeters. However, the reality is that there are millions of smaller objects, micrometeoroids and tiny fragments, that are too small to be tracked, but still pose a significant threat. Imagine trying to monitor billions of tiny projectiles traveling at Mach 20. Keeping track of each one is a Herculean task. So what does this mean for future space exploration? If space debris continues to accumulate at its current rate, it could become impossible to safely navigate Earth's orbit. Let's say we're planning a mission to the Moon or Mars with astronauts on board. The spacecraft has to pass through Earth's orbit, which is now a minefield of debris. What happens if one of those fragments strikes the spacecraft? Could a simple piece of junk from decades ago destroy a mission that cost billions of dollars? Could it jeopardize human lives? In the process, the answer is yes. If we don't act soon, the very infrastructure we've worked so hard to build could be compromised. Future missions that could take us to the Moon, Mars, or even farther, depend on our ability to manage space debris. In the coming years, nations and private companies are planning ambitious space missions. NASA is preparing for the Artemis program, which aims to land the first woman and next man on the Moon. Private companies like SpaceX are planning missions to Mars, while others aim to create permanent space stations in orbit. But how can we do all of this if the orbit surrounding Earth is too dangerous for travel? How can we launch new missions without facing the risk of space debris colliding with critical equipment? The future of space exploration depends on our ability to clean up the mess we've made in orbit. At this point, you might be thinking, what can we do about it? The truth is, there are solutions in the works, and some are already being tested. In the next section, we'll explore some of the groundbreaking technologies and strategies being developed to tackle space debris head-on. From using robotic arms to capture debris to innovative approaches like harpoons and lasers, the ideas are bold. But do we have enough time to clean up the mess before it's too late? That's the challenge humanity now faces. In the next section, we'll dive deep into these cutting-edge solutions. Stay tuned, because the future of space exploration might just depend on them. Now that we've understood the enormity of the space debris problem, let's turn our attention to the technologies and strategies that are being developed to tackle this growing crisis. The situation may sound dire, but there's a glimmer of hope, and it comes in the form of innovative solutions that are pushing the boundaries of space technology. Imagine this: a satellite in orbit, lost in the mess of debris, suddenly comes under the watchful eye of a space-cleaning spacecraft. Equipped with a robotic arm or perhaps even a net, this space janitor extends its tools and captures the errant piece of debris, securing it for disposal or deorbiting. It's like something out of a science fiction movie, but in reality, these kinds of missions are already being planned and tested. One of the leading ideas to tackle space junk is using active debris removal, ADR technology. ADR involves sending a spacecraft to physically remove or deorbit large pieces of space debris. The most famous attempt to demonstrate this technology is Clear Space 1, a European Space Agency (ESA) mission set for launch in the near future. Clear Space 1 will be tasked with capturing a defunct satellite, an object that has been floating in low Earth orbit since 2005. Using a specialized robotic arm, the spacecraft will physically grab onto the debris and then deorbit it, safely bringing it back to Earth where it will burn up upon re-entry. This marks one of the first steps toward actively reducing space debris. But while ADR systems like Clear Space 1 are impressive, they are just one piece of the puzzle. Another innovative approach to debris removal comes in the form of laser technology. This isn't the kind of laser you're imagining, a sci-fi beam that zaps space junk out of existence. Rather, this technology uses lasers to nudge debris into a lower orbit, where it will eventually burn up in Earth's atmosphere. The idea is to use ground-based lasers or space-based lasers to hit debris, creating a small force that can alter its orbit enough to send it on a trajectory that will end with it re-entering the atmosphere and disintegrating harmlessly. The Laser-Assisted Removal of Debris, LARD project, developed by multiple space agencies and private companies, has been testing this concept with small pieces of debris to see if it's feasible for large-scale operations. One of the four most remarkable ideas, however, comes from space-based capture techniques. In this method, a satellite equipped with a robotic arm or a harpoon is launched specifically to capture space debris. The harpoon would shoot out and hook onto large objects like defunct satellites, pulling them into a controlled orbit where they can be safely deorbited. Robotic arms, on the other hand, would work like a giant claw game, grabbing debris and either placing it into a secure storage area for re-entry or pushing it into a deorbiting trajectory. These concepts are being tested in a variety of ways. The Japanese space agency, JAXA, has already tested a harpoon-style system on its Kunotori mission to demonstrate the ability to capture and handle debris. This technology is still in its infancy, but holds incredible potential to change how we deal with space junk. Then there are the tethers, long, strong cables designed to drag debris out of orbit. These tethers can be used to either pull objects into the atmosphere or to direct them into safer orbits where they won't pose a danger to active satellites. Companies like Momentous and Astroscale are developing small satellite-based systems that can deploy these tethers, capturing pieces of debris and deorbiting them one by one. Imagine a fleet of small satellites orbiting Earth, each carrying a tether to capture and remove debris, one mission at a time. It's like clearing the clutter in space with a sweeping tool, slowly making the area safe for future generations of spacecraft and astronauts. But these techniques aren't without their challenges. For one, they require precise coordination, cutting-edge technology, and significant financial investment. Moreover, capturing space junk is a delicate operation. The debris could be tumbling in unpredictable directions or could be made of fragile materials. The slightest miscalculation could result in a failure, sending debris flying in even more directions, creating even more fragments. Additionally, there's the problem of scale. There are currently millions of pieces of debris. How do we address that much junk? It's one thing to remove a few large objects. It's another to deal with billions of tiny particles that are too small to capture easily. Some scientists and engineers are also considering the possibility of debris mining, the idea of repurposing some of the junk floating in space. If the debris is made up of valuable materials like metals or rare earth elements, it could be captured, refined, and used for new space missions. This idea, however, is still in its very early stages. The logistics of safely capturing and processing materials in space are incredibly complex, and the technology needed to refine space materials is still years away from being fully developed. However, the prospect of transforming debris into resources could help make space exploration more sustainable in the long run. Another consideration is policy and regulation. Even with the best technology in the world, space debris can't be addressed without a coordinated global effort. Countries around the world must work together to ensure that space missions are conducted responsibly, that deorbiting protocols are in place, and that new technologies are used to capture and remove debris effectively. The United Nations has already made strides in this area, creating guidelines for space sustainability. But enforcement is a huge hurdle. Who owns the space around Earth? Who is responsible for debris cleanup? These are questions that governments, private companies, and international bodies must answer together to create a safe environment for space exploration. One thing is certain: the problem of space debris isn't going away anytime soon. It will take a combination of technological innovation, policy changes, and international cooperation to keep space safe for future generations. The stakes couldn't be higher. If we don't take action now, space debris could become an even more insurmountable obstacle, putting satellites, astronauts, and future missions at risk. In the final section, we'll take a look at what the future holds. Can we clean up space before it's too late? What role will new technologies like artificial intelligence, autonomous satellites, and international collaboration play in this critical mission? Let's dive into the future of space debris management and the bold new solutions that could pave the way for the next era of space exploration. As we reach the final chapter of our exploration into space debris, it's time to ask the big question: can we really solve the problem before it's too late? The answer, much like the debris itself, is complicated. The path ahead is filled with potential, some of which is already unfolding before our eyes, but it's a race against time. If we don't act now, the very infrastructure we depend on for communication, weather forecasting, and space exploration could be compromised. But there is hope. There are bold visions, groundbreaking technologies, and a collective determination to turn the tide on this looming crisis. Let's imagine the future, a future where space is a safe and accessible frontier for all humankind. Satellites and spacecraft glide through orbit without the constant threat of collision. Space missions are launched without the looming risk of space debris. This isn't some far-off dream. It's a very real possibility if we take the right steps now. The key to making this vision a reality lies in a blend of innovation, international cooperation, and sustained investment. One of the most exciting developments on the horizon is the use of artificial intelligence, AI, and machine learning to monitor and track debris in real time. The idea is to use smart algorithms to predict the movement of space junk and calculate safe paths for satellites and spacecraft. Imagine an advanced satellite system powered by AI, capable of autonomously identifying, classifying, and predicting the trajectory of thousands of pieces of debris. This would allow for real-time decision-making to avoid potential collisions. In the future, this technology could be paired with autonomous debris removal spacecraft, allowing for automated cleanup efforts without the need for human intervention. While we're on the topic of automation, let's dive into how autonomous satellites could play a game-changing role in debris management. Imagine a fleet of small, agile satellites, each one equipped with its own debris tracking system and cleaning tools. These satellites would be able to not only identify and avoid collisions with space junk, but also actively capture and remove debris. Think of these satellites as space ambulances patrolling low Earth orbit, ready to respond to any debris emergency. This would significantly reduce the risk of collisions and, over time, could clear the orbit of thousands of smaller pieces of debris. But the future isn't just about removing debris. It's about preventing it from ever being created in the first place. Satellite design and mission planning are crucial to reducing the amount of debris we generate. In recent years, space agencies and private companies have been designing satellites with end-of-life strategies built in. Satellites are now being equipped with propulsion systems that allow them to deorbit themselves safely at the end of their missions. By ensuring that satellites are brought down from orbit in a controlled manner, we can prevent the creation of thousands of new pieces of debris. The space debris mitigation guidelines set by the United Nations and other international bodies are also helping shape these practices. By adopting these protocols, we could significantly reduce the volume of debris generated by future missions. Speaking of future missions, let's consider the colossal projects underway, missions to the Moon, Mars, and beyond. To reach these ambitious goals, humanity will need to use space more efficiently and more sustainably than ever before. One of the most innovative concepts being explored is the in situ resource utilization, ISRU strategy. Essentially, this means using the resources found in space, such as the Moon's regolith or asteroids, to fuel missions, build infrastructure, and even create new satellites. By leveraging the resources we find in space, we can reduce the number of launches we need from Earth, minimizing the risk of adding more debris to orbit. This would not only make space exploration more sustainable, but would also reduce the strain on Earth's environment, creating a more balanced and long-term approach to space exploration. Additionally, the idea of space stations that are self-sustaining, perhaps even with their own debris removal systems, could help serve as hubs for future space missions. These stations would act as staging points for astronauts and spacecraft on their journeys to the Moon or Mars. By incorporating debris management systems into these stations, we could ensure that orbit remains clear of junk, while also providing a safe environment for future missions. Space stations could evolve into recycling plants, where defunct satellites or rockets are dismantled and turned into valuable resources for new missions. But none of these innovations will succeed without global collaboration. The challenge of space debris is too big for any one country or company to tackle alone. That's why international cooperation is paramount. Spacefaring nations must work together to create global policies that regulate debris generation, encourage sustainable practices, and fund debris removal efforts. Just like the global efforts to address climate change, solving the problem of space debris will require a united front. As of today, we have agreements such as the Outer Space Treaty and the Space Debris Mitigation Guidelines, but the future will need to see even greater collaboration, perhaps in the form of a new binding treaty dedicated to space sustainability. The end space debris is more than just an inconvenience. It's a ticking time bomb that threatens the future of space exploration. But the technology, the vision, and the determination to solve this problem are already in place. What's required now is the global commitment to making it happen. The future of space exploration, from the Moon to Mars and beyond, depends on our ability to clean up the mess we've created in orbit. But the question remains, will we act before it's too late? Can we really clear the skies and ensure that the next generation of explorers has a safe place to launch from? What do you think? Is space debris the greatest threat to our space future, or is it a challenge we'll overcome, just like we've overcome so many others? The future of space is in our hands, and it's up to us to shape it. As we wrap up this journey through space debris, I want to hear from you. What do you think are the most promising solutions for tackling space junk? Drop your thoughts in the comments below. If you found this video informative, don't forget to like and share it with fellow space enthusiasts. Every conversation helps. Bring us one step closer to the solutions we need. The universe is vast, but it's also fragile. Let's ensure we keep it safe for future explorers, for our satellites, and for the generations yet to come.